Alright guys, so this is our solubility equilibrium crash course. I wanted to do this one separately from general equilibrium because it's a little bit different than the KC and the KP type expressions. So for KSP, that's when we have a solid and it's breaking into its cation plus its anion. So an example of that would be PbI2. That would break into make Pb2 plus 2I minus. This would be your solubility equation. It's always a solid breaking into its ions. What you need to know from here is when we write these KSP values or these KSP expressions, we don't include these solids. So these solids are never included. So we have KSP equals Pb2 plus times iodine to the second power right there. And the reason why it's second power is because it's always raised to its coefficients. One thing you need to know is that as KSP increases, the solubility increases as well. So if I have a higher KSP value, what that means is more of that substance can dissolve in water or something of that nature. So one thing that you need to make sure that you pay attention to that's a little bit different from KC and KP is molar solubility. Anytime they want molar solubility that is X, it is the amount of solid that can be dissolved, and it's measured in molarity. Okay, so this solid has whatever molarity we find that solid to be, that is your molar solubility. So one thing that they like to ask is sometimes they'll give you grams of the solid, and then they'll give you like liters of the solution or something like that. So what you can do is you can change those grams into moles, and then moles divided by liters, that will be your molar solubility, which is X. Another thing that they could do is they could give you a KSP value, and you'll have to solve for molar solubility that way. If you solve for molar solubility, you're basically setting up your Rice chart and solving for X for that. The next thing that's a little bit different is Q versus K. In general equilibrium, Q versus K is basically indicating like which way the reaction is going to take place. Q versus K for KSP does that as well, but it's also telling you whether or not a precipitate is forming. So if Q is less than K, then that means that the solution is unsaturated, and unsaturated means that it hasn't reached equilibrium yet, so you will not have a precipitate formed. If Q is equal to K, then that means that the solution is saturated, and anytime you see that word saturated, that means it's at equilibrium. If Q is greater than K, then we have a supersaturated solution, and that is the case in which a precipitate forms. So one thing that they could do with this concept is give you initial information, so like initial quantities for your solution, and they can ask if a precipitate will form or not. So what you would do is find your Q value. It's the same exact way of finding K, and then compare that to K. So if Q was greater than K, that means that the reaction is going to shift towards that solid, and that is where that precipitate is being formed. Another thing that they can ask is a common ion. Let's say we have PbI2 goes to Pb2 plus 2I minus. And they said that they added some solid NaI into this solution. So you're adding some NaI. NaI is your common ion because this iodine is going to break up, and that is common with what I have in my KSP formula. So what I do in this situation when they give me a common ion, this would essentially be 0, 0, plus X, plus 2X. What I do is whatever concentration they give me for the iodine, let's say it's just for instance 0.5 molar, that is what I replace this 2X with. So this stuff goes away, and I replace the 0.5 more with whatever this amount would be. The reason for that is because this amount that they give you for the common ion will always be greater than the value of 2x. Which will precipitate first? This is another question that they like to ask. So an example for this is if I have PbI2 versus CuI, and they're saying that they're adding iodine to both of these, and you're trying to figure out which one will precipitate first. The smaller concentration of what's common between them, so what's common is the iodine, the smaller concentration will precipitate first, because that means that it's less amount to add to cause that precipitate to form. So how I approach these is I write the equations for both. So CuI would break into Cu plus I minus, and then I would write the KSP formulas for both. So Pb2 plus I minus squared, and this one would be Cu plus and I minus. They will give you some information about the PB and the Cu, and they'll also give you KSP values. So what you would do is you would solve for the I minus concentration for both of these. And whichever one is smaller in concentration will always precipitate first. So that's how you work these type of questions here.